right, this is section 6.5. We're going to talk about trapezoids and kites in this section. All right, and this first shape is going to be a special quadrilateral. It's actually not a special parallelogram. So that is an error that is made, typo in the textbook too. So take off special parallelogram. It is a special quadrilateral. It is a quadrilateral. Is not a parallelogram because both pairs of opposite sides are not parallel. A trapezoid is a quadrilateral with exactly one pair of parallel sides. And those parallel sides are called bases. The non-parallel sides are called legs. The two angles that share a base of the trapezoid are called base angles. And you have two pairs of base angles, as you can see from the picture. Again, we're going to take off this parallelograms here. When we talk about trapezoids, we're mainly going to speak about isosceles trapezoids. And isosceles trapezoids mean that the legs of the trapezoid and the two sides that are holding up the parallel bases are going to be congruent. So think like an isosceles triangle has two equal sides. The legs of the trapezoid are congruent. That's an isosceles trapezoid. All right, and when we have an isosceles trapezoid, both pairs of base angles are going to be congruent. And remember, your base angles are attached to each base, which is the top and the bottom when it's oriented the way it is in the picture. So angle R here is congruent to angle A, and then angle T is congruent to angle P. And this next theorem is a way to prove that a trapezoid is an isosceles trapezoid. And it basically, if you know you have a pair of congruent base angles, then your trapezoid is going to be isosceles. So it just takes one pair of base angles to be congruent to make it an isosceles trapezoid. All right, in an isosceles trapezoid, the diagonals are congruent. So the diagonals of an isosceles trapezoid are congruent to each other. So here we are going to find the measure of angle D, angle E, and angle F. And I know from the information given that CDEF is a trapezoid, an isosceles trapezoid. So remember, with isosceles trapezoids, base angles are congruent. So angle C is going to be congruent to angle F. So that means angle F is going to be 65 degrees. Now we need to find D and E. And remember, I do know that quadrilaterals always add up to 360 degrees. So that means that I'm going to take my 360 and I can subtract. If I do 65 plus 65, we should end up with 130. So I'll subtract 130. And I get 230 left. And that means that D and E together are going to equal 230. So I'm going to have to take my 230, divide it by 2. So it'll give me a 1, or excuse me, a 0 right there. But 3 goes into it once. 1 left over, and 10. So we're going to end up with 115 for the measure of angle D and the measure of angle E. They're going to be both 115 degrees. All right, previously we talked about the midsegment to a triangle. Now we're going to look at the trapezoid midsegment theorem. And the midsegment of a trapezoid is the segment that joins the midpoints of its legs. The midsegment has two unique properties. It's going to be parallel to both bases, and just as in the triangle, the length of the midsegment is half. Now this time, though, it's half the sum of the lengths of the bases. So you want to add those two bases together, divided by 2, and that will give you the length of the midsegment. So again, take both bases, add them together, divide it by 2, or multiply by 1/2. And that gives you the length of the midsegment. All right, so here we are tasked with determining the length what the value of x is. And we are told that segment QR is the midsegment of trapezoid LMNP. So again, remember, I know that my midsegment, my x plus 2, is going to be equal to half the sum of the other two bases. So 4x minus 10 plus 8. And I can keep it x plus 2 is equal to 1/2 times 4x. Negative 10 plus positive 8 will give me a minus 2. If I distribute my 1/2, I'll end up with x plus 2 equals half of 4 is 2, so 2x. Half of 2 is 1, so 2x minus 1. Now we're going to solve for x, so I will subtract x from both sides. So I get 2 is equal to x minus 1. Add 1 to both sides, so x is going to be equal to 3. My value of x is 3. All right, our next special quadrilateral, and again, it's not a parallelogram, it is a quadrilateral, so take that parallelogram off, is a kite. And a kite has two pairs of consecutive sides that are congruent, but no opposite sides are congruent. And we will talk about the angles, sides, and diagonals of a kite as well. So the diagonals of a kite, if a quadrilateral is a kite, then its diagonals are perpendicular. So just like with the rhombus, the diagonals are going to be perpendicular in a kite. In a kite, you also have one pair of opposite angles that are congruent. That pair of opposite angles that are congruent, I want you to think about where the two sides come together that do not have the same measure. Those angles formed by those two sides, so where the two opposite angle measures come together, or the opposite side measures come together, those angles are going to be congruent. So the angles that are formed by the two different side measures are going to be the two angles that are congruent in a kite. All right, and the last thing we're going to do for 6-5 is we are going to find the measure of angles 1, 2, and 3 for this kite. If you recall, one thing that we talked about in the past slides is the diagonals of kite are perpendicular to each other. So that means right away I can tell that angle 1 is going to be 90 degrees. Now, I know that angle, GDF, this angle right here is 52 because they gave it to me. So, you know what, we have a triangle here. I can find angle 2. And I know that if I do 180, and actually because this is a right angle, I know that angle 2 and the 52 degree angle are complementary. So I'm just going to do 90 minus 52. And that is going to give me 38 degrees. So angle 2 is 38 degrees. Now we do need to find angle 3. I'm going to erase some of the stuff I put on there already. Okay, so we do know that angle 1 is a 90 degree angle, so this is a 90 degree angle. We do also know that these two sides are the same, and if we were looking at these two triangles here, this triangle right here and this one right here, through my reflexive property, I know that's the same. So I know through HL theorem, hypotenuse leg, that this triangle is congruent to this one. And that means if angle GDF is 52 degrees, then the measure of angle 3 is also going to be 52 degrees. And again, through our HL theorem, because we know that these two sides are the same, and then we have a right angle here, so DE and DG are hypotenuses. And then we have a leg through our reflexive property. That means the two triangles are congruent. So if this angle is 52, then angle 3 is also 52.